Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be looking at startup scripts for Alpine Linux on Raspberry Pi. It's going to be a fun and exciting adventure, so let's go ahead and go right into it. So what we're looking at here is this is the same installation that we had for the actual installation procedure video that I showed for the Raspberry Pi on Alpine Linux. But this is actually the actual default installation that we did in that video. It doesn't include any of the additional stuff that we did afterwards. And it's just to kind of keep things clean as possible, just because it can get a little bit messy. So what we're going to be doing today is we're going to be writing a script that actually modifies the message of the day, or the init.d file. And what it's going to do is it's going to update it with the current time at boot, and then it's going to automatically run that every time that it runs. This is useful if you want to run your own scripts, things like that, on startup without a user having to be logged in, and also automatically as soon as it boots up. So if you want to run services, things like that, that you build yourself, this is the same procedure that you would do it. We're going to write everything from scratch in text files and actually add those to the init process to be able to get those running. So let's go ahead and get started. So first thing we're going to do is we're going to create a bash script. And that bash script is going to actually be the thing that modifies the message of the day file. So I'm going to use Vim just because it's comfortable for me. You could use Nano as well. We covered those in other videos. And we're going to name it update motd time.sh. Next, we're going to add pretty much a declaration telling it what interpreter to use in order to run this code. And it's colloquially referred to as a shebang statement. And it's a hashtag, an exclamation point, and then the actual path to the interpreter. In this case, we're going to use shell, which is sh. So it's going to be /bin/sh, which is the location of that interpreter. If it was Python, it would be /user usr/bin/python, just as an example. But it's pretty much any interpreter that you wanted to automatically use when you run it without calling the interpreter explicitly. So since we're writing a simple script, a simple interpreter is actually the way to go. So next we're going to get the current time. And we're going to do that by setting a variable called current time. And there's no space after the equals intentionally, otherwise it messes it up. But if you're setting variables in shell or bash or ash in the case of Alpine Linux, you don't want to put a space after the name of the variable. Otherwise, it won't set correctly. It'll treat it as a logical operator and error out, or at least not do what you expect. And then we're going to put a $sign. And a $sign in bash and shell scripts, I'm going to just say shell scripts or bash interchangeably, just out of habit. But it's pretty much indicating that it needs to do something. So the interpreter actually needs to replace it with something. And it's called substitution, technically. But it's we're going to add in a command. So we're going to put a parentheses, and we're going to put the command date, a plus sign indicating that we want to specify exactly what it's going to print out, opposed to printing out the default. Then we're going to put quotes, %y, which is short for year, dash, % lowercase m for month, %d, lowercase d for day, a space, %capital H for hour, %capital M for minute, and then a colon, %capital S for second. And just because I like to do this, I always like to include the time zone setting, because if you don't have your Linux installation set correctly and you have it set to UTC, midnight is very different as far as time versus like the East Coast of the United States where I'm at. So I also like to include %z for time zone. And that will give us our current time zone setting. That way, everything's already incorporated and it is a complete actual date string. So we'll skip down a few lines and we're going to update the actual MOTD. Message of the day. And that's what the message of the day is it's the first message that pops up after you log in. And that is for both SSH as well as through the local console. And sometimes you can actually put like security messages in there. You can put down, I usually like to put in what machine I'm logged into, like what the function is. And especially some like critical strings, especially if this is just something that you're building for yourself, if it keeps working for too long, you're going to forget how to do it, you know, if you don't write things down. So I actually find it useful to write down, you know, the names of the critical services on that machine and what the commands are in order to restart those. So in case there is a problem, the resolution is very quick and easy. But in this case, we're just going to use it as an easy way to be able to check it. And then from there, you know, we could see it any time we want when we log in. And you can follow along at home if you're going to do these tutorials and follow on your own Raspberry Pi and your own Alpine Linux installation. It'll work for you as well. And it should be a lot of fun and get you started in terms of actually creating these types of startup scripts. So let's actually add the echo command. I've kept you in suspense long enough. So we'll say, welcome to Alpine Linux. And then we're going to call it the startup time. And then we're going to put our variable that we just set, which is current time. And close quotes. Now, key thing is that we're using double quotes. If we use single quotes, it would actually take that variable and just print it out literally. But because it's in double quotes, it will replace the $sign variable because we set it up here without the $sign. But when we call it again, we tell it we want it to substitute it. So we use the $sign and we put the variable name. So that way it will actually replace that value. And then we put the caret. And what this caret does is it will actually pretty much pipe the output. And what piping is means that it'll take everything that comes out of this command and send it somewhere else. But it will pipe it into a file that, in this case, is the message of the day file. So /etc/motd. No extension on there. And that's it. And I usually like to put a new line at the end. A lot of that actually is probably more stemmed from Git, because Git likes to see the line, the new blank line at the end. So it should still run fine, but it's just a good practice to get in the habit of doing is always include an empty line at the end. So we'll save that out. And now we want to make it so we can execute it. So we'll do chmod +x /bin /update motd -time.sh. Hit enter, and now that's done. So now we move on to step 2. And step 2 is we're going to write the init script. So let's VI to that location. And pretty much everything that's the init scripts is going to be in the /etc /init.d folder. And then we name our file. And it doesn't need an extension. I mean, the extension won't matter, I'll put it that way, because it's going to run underneath the init interpreter. So it has its own syntax, own everything else like that. And we're just going to cover a very high-level example at first, but we'll go into a more detailed example later. So we're going to do the shebang again. And this time we're going to use sbin open rc run. And that's just the interpreter that we have to use in this case. So it's going to run it as an OpenRC init file. So next we'll define pretty much the minimum that we need. We're going to call it's the start function. So this start function is going to be called when we do things like start, etc. But this is where we're going to define the actual script. So we're going to put the path to the script that we just created. All right, and that's the full path. And then we close our parentheses, put a new line at the end, and save it out. And that's the minimum that we need in order to get it to start. But I will say there's a few problems with this. And it is that it will only run it once, and it will run it in the foreground. Now, what I mean by the foreground is that it will show up on the terminal as the machine is starting up. So you can't put loops or anything like that that runs infinitely with this particular example, but with the next example we do, we'll show running the process in the background, and that will allow you to be able to do infinite loops without blocking the machine. So let's also give this executable permissions. Perfect. So now the next step is we can register it as a startup service. So we're going to do rc update, add the name of the file, so it's rc update, add update motd -time default. And default just means that we want it to start and stop at the default run levels. Because in addition to starting it automatically when the machine starts up, it's also going to stop it gracefully when the machine is shutting down or restarting. So it's important to make sure that you have the levels correct. There are other levels to use, but generally they're used for low-level services like networking. So it's just something to keep in mind. Default is usually the default thing that you will use. Perfect. So before we restart, because obviously it's not going to save anything at this point, we haven't done LBU, if you remember from our previous videos. So let's go ahead and actually run it and make sure it's working before we start committing it to start on the next startup. That way, if we messed up or something goes completely wrong, we could just restart the machine and it'll erase it all, and that way we're back to normal. So we'll do /etc /init.d. Right? So that's actually the name to the init file that we just created. And we're going to say start. So we see it says caching service dependencies. Okay, and it comes back to the command line. And now if we go to status, we see that it says that it started. So looks good. Let's see if it actually updated the message of the day. And it did. It looks like it did it at 1:13:49. It is early in the morning here. Right? But it's not changing. So we could restart it, which will pretty much stop the service and then start it again. And then when we look at the output, we see that now the time has changed as well. So it's doing what we expect, but it's only updating it once on boot. But that's fine for now. So if we just wanted something to start when the computer started up, we could use this to be able to do this. There are other ways to do it, like cron scripts and things like that, but we're not going to go into that here at this point. But this is just the way to do it as a service. And part of the advantage of that is you can actually have it do other things when it stops, where you can't do that with cron. It will just run on a schedule. So just something to keep in mind. So now let's add it to LBU. We know it's working. So we want to do LBU add, and then we want to do the name of our shell script because it's in the bin folder, so it's not going to save by default. So we're going to do /bin and then /update motd time.sh. I did auto completion in this particular case. And we're going to hit enter. And then we're going to do the same thing for our init file. So now we've added both of the files that we created to the LBU list. And if we do LBU diff, we can actually see what those changes are, and we see the files that we added, everything else like that. And that's the only difference that's in LBU. But we don't necessarily have to care about that, but we do see that our files have been successfully added to LBU, but now we need to actually commit it so it's saved for next startup. So we're going to do LBU commit. And actually, if we wanted to delete all the other versions, we would put the -d at the end. But in this case, we'll just keep it as is. So now that we've done that, we can actually reboot the system. So I just rebooted it. The shell disconnected. I'm going to give it a second here in order to fully reboot. And I could probably hook up a cable to it, but that seems like a lot of work. So we'll give it a second here. While we're waiting for that, if you guys are enjoying the video, if you find any value in these videos, be sure to hit that like and subscribe button. It definitely helps me out a lot. And if you have any questions after the fact, leave a comment down below. I'll read them and respond to them, as best I can. So let's see if it's come back. All right, and it's asking us to log in. We're going to log in with the credentials that we set up the last time around. And there we are. We see our message of the day printed right here. And we see the startup time was 1:17:30. So pretty much it's doing what we expect. So let's say we wanted to update the actual time in the background continuously. And this gets a bit more advanced. Because right now, if we just look at this, if we logged in later, we would still see the same startup time. So if this machine is on continuously for over a year, the startup time is interesting, but it doesn't necessarily show that we're running a service in the background. Because the service could crash out, or somebody could stop it, and we wouldn't see any difference because it only runs once. So to run a perpetual service, we want to run it in the background. And the reason we want to run it in the background is that way we're not waiting for it to do anything. So it won't delay the actual boot time of the machine. It will just launch it and pretty much forget about it and leave it to its own devices. So let's go back in and edit our message of the day file. And let's make it so it loops. And pretty much all we're going to do is we're going to add while true, do, and then done at the end of it. Right now, in order to make it so it doesn't go into a race condition, and I'll add some space here just to make it understandable of what hierarchically it's doing, we're going to add a sleep 1. Okay, and what sleep will do is make it so it pauses the execution of the script for 1 second and then resumes. So it will run this loop once per second, and that will actually update the script. So we save that file, and now let's update the init script. Now, all of this is great for a basic example, but we're going to need a bit more if we're going to do the advanced example. So we keep the same shebang because realistically that's going to stay the same. We're using the same interpreter. And we're going to set a variable called name. And we're going to have it set to a variable that's already created by just by the virtue of running openrc-run, which is we're going to get the service name. So this is something that's set as an environmental variable during runtime, which allows us to be able to leverage it so we know what it is. So we can actually create these scripts so they're pretty generic, but still are unique when they actually run. Right, and then we'll define a config file. Right, so we just did the same thing. So it's going to place a config file in /etc/rc underscore service name, rc underscore service name. And in this case, we don't have anything there, but that's perfectly fine. And then we're going to tell it what command to run. And in this case, we're going to give it the path to our actual script. So /bin /update motd time.sh. And then something else we could put is command args. In this case, we don't have any, but if we had to put like additional flags at the end of it, we would use this in order to set that. It does have to be defined separately. You can't put it in command or it won't run it appropriately just because of the way that OpenRC runs this particular command set. So it has a separate variable for that. Then we can tell it what user to run it as. And because we only have the root user right now, we're going to run it as root. If we created other users, this would be the place to set it. Because obviously, if it doesn't absolutely have to run as root, it's better actually not to run it as root. And then we define the PID file. And what the PID file is process ID file. So when it actually starts up, it's going to assign it a process ID, which it will use in order to track whether it is still running or whether it has died or anything else like that. Even though it's running in the background, it won't actually monitor it. It will just monitor the actual PID reference. So we need a place in order to store that PID. That way it can keep track of it. So for PID file, we're going to put it in the run folder. And we'll just do RC service name and then /RC service name.pid. Okay. So now we have our PID file, and then this is the critical command that actually makes it run in the background. So it's going to be command background. Yes, we want it to run in the background. If we put no, it would run in the foreground. So if it was infinitely looping, things like that, it would stop your computer from booting fully. So just something to keep in mind. Generally, this is always going to be yes, unless it runs once. Now we're going to actually have it do pretty much something that I call a formality, but is a best practice, which is to do a start pre. And what this will do is every time it starts, it will run this before it actually starts the script. And what we're going to do is check path. And check path is something in OpenRC run that will pretty much create all of the necessary subdirectories, PID files, everything else like that. Make sure you have access to it. So that way, if something's going to error out as far as setting up the constituent items to be able to run it as a service, it will fail before it actually starts it. So you don't get a bad start or a really weird running state. So that's why it's best practice in order to do this. So we're going to check directory, the owner. It's going to check whether we have write permissions to it or the appropriate access permissions to it. And then I'm putting this escape character just so I can put it on the next line, just so we don't loop in or wrap in a weird place. And then we're actually going to put the paths to the two areas we wanted to check. And something I'm actually putting here is a log directory. So if we did generate logs and we wanted to put them in a directory folder inside of our log, this would check that as well. So it doesn't hurt to keep it included in this. And that concludes start pre. And that is all that we need. So pretty much, because we are entering the command, it's going to automatically run the command that we set as well as the command arguments. We don't have to define start explicitly because start is already implied. There's a default start inside of OpenRC. So we just defined the start pre. And technically, we don't necessarily have to provide that as well. We could just provide the command and all of the things here at the top, and it can actually figure it out from there. Now, this is not the case for all operating systems, but this is the case for Alpine. And as part of the reasons why I really like it is they use a lot of very advantageous packages that really make things easy. So let's save this out. And let's actually make sure it's going to work. So let's do /etc/init.d update. And because we already have it running, we're going to do restart. And we're going to see it's doing a few extra things. And notice the start stop daemon. And what that's doing, it's trying to stop what was already running, but because we weren't running it as a background daemon, there's obviously nothing defined, so it shows up red. So it did stop it successfully, but it didn't actually use the start stop daemon. So a way to avoid this particular error would be to stop it before you edit the file, because again, when you start and stop it, it's going to run that init file fresh, but as it appears right now. So it won't cache whatever the last version was. So if you do change that, be sure to be cognizant of that. It is a good practice to just stop it first. And we see it created the directory, and it created the log directory, which are the two things that we asked it to in the start pre for the check path. And then it started it, and now we can check it. So let's go ahead and use another command, which is called watch. And watch is a useful command because it will do something on an interval. So if you have it's kind of like running a loop and just echoing something out to the screen or catting something out to the screen. But in this case, it's kind of implied. So we'll watch a file every second. So the -n is how many number of seconds. So every 1 second, we want to cat /etc/motd, message of the day. So we hit enter, and if we look, we see that the second hand is changing. So it is in fact updating the file once per second. So if we were to restart the machine, we would actually see that the second that it would say would be the one that we logged in. So in reality, it's not the startup time anymore. And I hit Control-C to exit that. So if we actually go in and edit the file, we don't want to call it the startup time anymore. We're going to call it the login time because it's going to display it once as soon as you log in. We want to make sure that it's clear what time this is referencing, because once it displays, it's not going to update for the user anymore, but it will keep updating in the background. So if you open up multiple windows, they may all potentially have different login times, or if multiple users log in through SSH or through the console, they will all have different login times. But the login time will be the current time that it was set to when you logged in. So we'll write that out, and we can restart that again. And this time we see it didn't have to create anything. It just stopped and then started again. And if we go back to the watch command, we see it says login time. So let's Control C out of that, and let's commit these changes. So we'll do lbu commit. So now we can actually do a restart. I'm sorry, reboot, brain fart. So we'll reboot the machine, and then pretty much once it comes back, we'll be able to see that the time that we log in is the current time that it was set to, and that will be, no matter how long we wait, it will always be the actual time that we log in, or at least as far as the machine's perspective is. Now, granted, it doesn't have a real-time clock on the Raspberry Pi. We could add one, but in this case we haven't. This is just the stock Raspberry Pi. But it is updating its time from NTP using Crony. So as a few seconds after login, as long as you don't log in too early, it should be a very accurate time as long as it has network connection. All right, so it's pretty much there. Let's try logging in. And there it is. And that is indeed the current time. So, and if we log in again, we would see the same thing. Let's see. Oh. So root, the password, and we see it's a different time than what we had before. So that's what we're looking at, is that it's able to run the service in the background. We're able to do other things while this is happening. It fully starts up. You know, we can go to top. We can see that it's doing things, but it's not taking up a particular amount of actual process time, but it is occasionally popping up as it updates once per second. But then it's sleeping for the rest of the time, so it's very code efficient in terms of not taking over the entire computing resources of the Raspberry Pi as it's doing this. So we could do other more useful things in the meantime, or run multiple services if we needed it to do things like that. So I hope this was helpful in terms of showing how to create the login scripts and everything else, like as far as the simplified example as well as the advanced example, just to get you running on pretty much what you need in order to create a usable little server out of the Raspberry Pi on Alpine Linux. So if you like the video, be sure to hit that like button and leave a comment down below, and share with friends. If you think somebody will be interested in this, definitely spread it around. And if you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.